Welcome, Pathogen Pirate. You are Pathogen Pirate, and your goal is to complete 7 tasks in this quest in order to find the hidden treasure. The hidden treasure is marked with an X on the map. Each task will teach you about your immune system. You'll record the information you learned in each task on your game sheet assigned in Google Classroom. Are you ready? Let's go. Task number 1. This is all about types of organisms that cause infectious disease. The immune system protects the body from worms, germs, and other agents of harm. Here are some types of examples of pathogens to record on your game sheet for number 1. You can choose any of these, you just need 4 of them. So you need the type, that's in the left column, and then what they cause. What they cause is in the right column. Go ahead and pause this video and fill in those answers on your game sheet or either write them down on your paper. This is your Pathogen Pirate game sheet, and this is where you'll write down all of your answers. So for the very first question, on task 1, it says, please list 4 other types of pathogens and include an example of an infection caused by that type. So we see an example right here, parasitic worms, and an infection caused by that is hookworm. So another example of what you could add on your game sheet is bacteria. And that causes things like strep throat, staph infections, tuberculosis, food poisoning, tetanus, pneumonia, and syphilis. You don't have to put all of those, just pick one. Task number 2. This is all about different ways diseases are spread. There are 6 main ways. 1, person to person. 2, droplet. 3, fecal to oral. 4, airborne. 5, fomites. Or 6, an insect bite. And below each of these, it says how the transmission works. So on your game sheet, you want to list and describe 4 different ways that diseases are spread. So use this for task 2. Task 3 is all about the immune system's job. This is going to be a video. You're only going to watch the very first minute. I'm going to play it for you. After that, on your game sheet, you're going to answer the 3 questions. What did you learn? What surprised you? How does it relate to something you've learned in this class?
A mosquito lands on your arm, injects its chemicals into your skin, and begins to feed. You wouldn't even know it was there if not for the red lump that appears, accompanied by a telltale itch. It's a nuisance, but that bump is an important signal that you're protected by your immune system, your body's major safeguard against infection, illness, and disease. This system is a vast network of cells, tissues, and organs that coordinate your body's defenses against any threats to your health. Without it, you'd be exposed to billions of bacteria, viruses, and toxins that could make something as minor as a paper cut or a seasonal cold fatal. The immune system relies on millions of defensive white blood cells, also known as leukocytes, that originate in our bone marrow.
Task 4. This is all about your first line of defense. The first line of defense has 3 parts to it. There are physical barriers, and there are chemical barriers, and there are biological barriers. Physical barriers physically block pathogens from entering the body. The skin is the largest physical barrier. This also includes your mucous membranes, so think like your nose. Chemical barriers. These destroy pathogens on the outer body surface, at body openings, and on inner body linings. Examples of these are sweat, mucus, tears, and saliva. Biological barriers. These are living organisms that help protect the body. Millions of harmless bacteria live on the skin and in the gastrointestinal tract, or you might have heard that as GI tract. They use up food and take up space so harmful bacteria can't grow. So pause the video to answer the question for task 4. Task 5. If things get past the first line of defense, then we have the second line of defense, and this is the inflammatory response. In this, bacteria invade your tissue, and in response, cytokines and histamines are released that cause capillaries, so capillaries are your tiniest blood vessels, to dilate and become leaky so that they attract leukocytes. Leukocytes are white blood cells that can kill off those toxins or bacteria. Tissue repair proteins and other substances seep through those leaky capillaries into the infected tissue to help out. And then leukocytes can also leak in through the capillaries and phagocytize bacteria. Phagocytize is just like a word for it could basically eat it. Task number 6. If things get past the first and the second line of defense, the third line is there. This is called the immune response. It is a specific line of defense, and it's the third one. The following 2 responses may happen if a pathogen gets past the first and second lines of defense. You might either have the humoral response or the cell-mediated response. These 2 have a lot more details, but we've narrowed it down to just the main overview. The humoral response is in your blood and your lymph. This includes antibody release from plasma cells. The cell-mediated response mainly involves cells called T cells. Go ahead and pause the video to answer the question for task 6. Task 7 is our last task. This is all about antibodies. We are going to watch a short video to answer the questions for task number 7.
Hello everyone, this is Dr. Bishop, the Director of Wellness at PartnerMD. This video is going to talk about antibodies. So lots of people have questions about antibodies. What are they? How do they work? What's their function? How does the body create them? And so we're going to talk a little bit about that in a Khan Academy style video here. So I've got a whiteboard and we're going to walk through what antibodies are, how they get created, and what their purpose is. So let's start off with considering the viral particle. So when a virus gets into the body through whatever means, blood, tissue, whatever it is, and we're going to draw the coronavirus here. So it's got this central spherical look to it with all these projections that come out of it looking like a crown, which is where the idea of corona comes from, and then coronavirus. So it has all these projections. So what ends up happening when a viral particle, or frankly anything that's a foreign object that's not supposed to be there, gets into the body, it gets noticed. It sets off some alarm signals to the immune system saying, hey, there's something here that shouldn't be here. And then white blood cells will come and be in the same location as the viral particle. They will take note of these things on the surface typically first and say, hey, yeah, this is definitely foreign. And so the white blood cell will actually engulf and eat these particles up. And so it kind of looks like a little bit like an egg at this point. With this giant viral particle, of course, white blood cells are many times larger than a single viral particle, so it'll look quite a lot smaller under an electron micrograph or a super microscope. So, but regardless, the white blood cell gobbles up the viral particle and then takes it back to another part of the immune system that most people are familiar with. Typically, it takes it back to a lymph node. And all a lymph node is a collection of specialized immune cells. So you get your white blood cell in here, and then it's got the coronavirus in the middle, and we're just going to do a general representation here. And what the white blood cell will do is it will actually break apart the coronavirus into pieces. It gets degraded, and so you've got these pieces of viral particle here, and then the white blood cell will present these, what they're called now, antigens, or the pieces of the virus that might elicit immune response to another special type of immune cell called a dendritic cell, and there's some other cell types here. But the white blood cell shows these things and says, here, look what I found, to the dendritic cell. And then the dendritic cells start a whole process in the body of creating antibodies. So they send a lot of signals to B cells, which are a type of blood cell that create the antibodies. And they start producing, eventually, a type of antibody called IgM. So once the body starts creating antibodies, there's a number of classes or different types of antibodies. But the first type that's typically created is something called IgM, and it's just the first class of antibodies. They're not as specific and powerful as later antibody classes, but they come out first and they come out rapidly, which is very helpful in controlling infections right away. Most antibodies are shaped like this, and they can sometimes link together in rings or different structures, but ultimately they're shaped in this sort of Y conformation. And what happens is these parts of the antibody up here, which we will kind of highlight a little here, these parts of the antibodies up here are the parts that are specific and can attach to whatever viral particle antigen it needs to be attacked. So we've got here now an IgM antibody that's been created by our B blood cells. We've got our viral particle coronavirus over here. So typically what's going to happen is one of these external antigens or these external projections is what's going to be targeted by the immune system. So the IgM antibodies, and with this part here, they're going to recognize these things, and they're essentially, you can think of them like magnets. They're going to come across, and they're going to float around in the bloodstream or in a tissue, until they come into contact with the coronavirus piece, and they're going to say, you're not supposed to be here. And they're going to act like a magnet, and they're just going to start attaching themselves to the viral particle. And what happens is the viral particles sort of get coated in antibodies. And I won't make you guys sort of tediously sit here and watch me draw them all around, but they get coated with antibodies. This then sends more specific signals via this part of the antibody molecule here at the end to more white blood cells. And it basically is a sort of a high-level warning signal. It says, hey, this is not supposed to be here. Not only is it dangerous, white blood cells, please come immediately and attack this thing. So you have more recruitment of white blood cells, and they attack these things and take them again back to lymph nodes to create more antibodies over time. And then you end up recruiting other types of white blood cells called T cells and other things too that come and attach themselves to any cells that have been infected with virus and start killing those cells and destroying them in an effort to contain the viral infection. So that's sort of the IgM response. Eventually, over time, what happens is the body creates other types of antibodies. Again, like I said, the first type here is called IgM, and those are your acute infection antibodies. Those are the ones that are created first, and then later, after you've been sick for about a week or two, these sort of special forces antibodies, that's IgG, special forces antibodies get created over time, and they're much better at controlling the infection long term. They look more or less the same as these antibody types, but they're even more specific and more powerful at detecting the viral particles, and they attack the viral particles as well and assist the immune system with destroying these things. And so when we come in and do lab tests, what we test for are these two. So again, there are other classes of antibodies. They're not as critical to this discussion, but we test typically for IgMs saying, hey, you recently acquired this infection. You may not have gotten over it yet. It's probably still going on. And then we test for IgGs, which show, hey, you've already mounted a good immune response to this virus, and you've nearly, in most cases, you've nearly defeated it and are well. Sometimes in the middle, when you're on the upswing of getting better, you can have both types of antibodies present at high levels in your bloodstream. But generally, these IgMs are the first ones to appear. They go away after a couple weeks. The IgGs, they appear after a week or two, and they stick around for months or years to provide ongoing protection from the virus should you get re-exposed to it. So that's a general overview of how antibodies work.
On your game sheet, you're going to want to answer the 3 questions about that video. What did you learn? What surprised you? And how does it relate to something you've learned from this class? And that is all your tasks. So you want to make sure that you answered all the questions for each task. If you need to go back in the video, you can. When you're done, you will turn this into Google Classroom. If you hand wrote your answers on paper, or any combination, like if there were some you wanted to write on paper, like the video questions, then go ahead and take a picture of those and add them as an attachment to your assignment on Google Classroom. Arr, matey, congratulations, you've found the treasure. Nice work, and make sure you turn this in to Google Classroom.